The entire universe, every electron, proton, atom, every star and galaxy, was born out of a singularity that brought about our whole existence. The Big Bang, an isolated moment in space and time, created something out of nothing. For eons we didn't know much about the universe, but through advancements in science and technology, we're now able to travel back in time, right to the point just after the Big Bang to finally piece together its entire story. And in the next 10 minutes, I'll be sharing that story with you. To be able to understand the history of our universe, we have to start at the beginning of time, and time itself was born with the Big Bang. Contrary to what its name might suggest, the Big Bang was not an explosion. It can more precisely be described as the rapid expansion of space and time in all directions, releasing immense amounts of radiation. In 1964, two Americans, astronomer Robert Wilson and astrophysicist Arno Penzias, stumbled upon a cryptic message traveling from the moment of creation itself. Their antenna in New Jersey picked up an odd buzzing sound that puzzled them. After eliminating all possible sources of interference, Wilson and Penzias figured out that they had just discovered the cosmic microwave background, or CMB, the thermal echo of the universe's explosive birth, and the most crucial piece of evidence for the Big Bang. Thanks to this ancient message, we know our universe came into existence 13.7 billion years ago, and it immediately began expanding at an exponential rate. This is known as the inflation epoch. When it was less than a blink of an eye old, like a billionth of a trillionth of a second old, our universe underwent an astounding growth spurt faster than the speed of light. Within a fraction of a second, it doubled in size at least 90 times. But as it expanded, the energy released became more diluted. In just 3 minutes, the universe had cooled down enough to allow the first particles of matter to form, and the first light elements were created. Neutrons and protons began colliding with each other and formed hydrogen, helium, and lithium. Though the particles were formed, the intense heat from the moment of creation made it too hot for light to shine, and so our universe was plunged into a cosmic dark age for hundreds of millions of years. Space was desolate and devoid of any planets, galaxies, or stars. Then the age of re-ionization began, and light finally emerged from the darkness with the birth of the universe's first stars, known as Population 3 stars. These are believed to be made of the only ingredients available in the universe at the time: hydrogen, helium, and lithium. These stars are time capsules rich with information about our universe's earliest days, and with the James Webb Space Telescope, we can now look into them with greater detail than ever before. About 1 billion years after the Big Bang, galaxies began to appear, and there are two theories on how they first came into existence. The first suggests that big clouds of gas and dust collapsed under their own gravitational pull, allowing stars to form and eventually galaxies. The second, which has gained momentum in recent years, suggests that galaxies formed when small lumps of matter kept clumping and swirling together until they eventually grew to the size we're familiar with today. Our galaxy, the Milky Way, is roughly 13.6 billion years old and contains between 100 to 400 billion stars, and spans about 100,000 light years across. Astronomers are still working on charting the spiral structure of our galaxy. Although using infrared images from NASA's Spitzer Space Telescope, we've discovered that it is dominated by two arms wrapping off the ends of a central band of stars. Stars and galaxies are still being created to this day, and astronomers estimate that there could be as many as 2 trillion galaxies spiraling through the black ocean of our universe. 4.5 billion years ago, a dense cloud of interstellar gas and dust kept swirling together. As gravity pulled more and more material into the center, the pressure in the core was so great that hydrogen atoms began to form to make helium, releasing immense amounts of energy. This process eventually gave birth to the star we see every morning when we wake up, our sun. Once the sun was formed, the matter surrounding it clustered into spheres and fell into its gravitational pull, creating the planets in our solar system. The giant planets, Jupiter, Saturn, Uranus, and Neptune, were the first to circle the sun. As it began emitting its light, the smaller planets Mercury, Venus, Mars, and our very own Earth formed. Our planet just happened to orbit the sun in what scientists call the Goldilocks zone, the perfect temperature and distance from the sun to allow for liquid water to exist. Somewhere between 60 to 175 million years after our solar system was born, a Mars-sized planet collided with Earth, and the post-impact debris morphed together to give us our moon. Talk about upcycling. Life in our universe seems to be far from inevitable. Everywhere we point our telescopes end up seeing the same thing: bright nebulae, star clusters, and ominous galaxies that all look desolate and lifeless. But when it comes to our home planet, the story is very different. Life on Earth first appeared 3.7 billion years ago, but how it sprung into existence is still a hot topic of debate. Many believe the first living organisms were microscopic microbes that left signals of their presence in rocks. Others think life started in a primordial soup deep in the ocean through vents in the seabeds, where the interaction between water and rocks provided enough chemical energy to allow the first unicellular organisms to emerge. Whichever side of the argument you're on, though, the one thing that's certain is that the Earth was teeming with life long before we showed up. We came onto the cosmic scene just around 6 million years ago. A long time for sure, but minuscule when compared to the 13.7 billion year lifespan of the universe. Although our early ancestors joined the party late, we've moved quicker than we could have ever imagined. In just a short span of time, we've gone from hunter-gatherers to cosmic explorers preparing to create a base on the moon's surface. Our telescopes now allow us to see further than we've ever been able to before, and our questions are bigger than we've ever dared to ask. But even with all the tools available to us, there are things in the universe that are still shrouded in mystery. Around 85% of our universe is made up of a mysterious substance that we have never seen. In 1933, Swiss astronomer Fritz Zwicky measured the visible mass of a cluster of galaxies and found that it was too small to prevent these galaxies from escaping the gravitational pull of the cluster. Zwicky concluded that something must be acting like glue holding the cluster together. That mysterious substance we now describe as dark matter, a completely invisible material that fills up our universe and acts as an astronomically potent superglue. Without dark matter, the behavior of stars, planets, and galaxies would just not make sense, and our universe would not have evolved the way it has. And then there's dark energy, the strange force that is pulling our universe apart at an ever-increasing speed. Just like dark matter, dark energy is invisible, but its powerful effects are largely felt.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
In 1920, Edwin Hubble discovered that the universe is not static, but is still expanding. And in 1998, the telescope named after the astronomer proved him right. And even more, that the universe was expanding at an accelerated rate. We have since discovered that dark energy is the reason for this expansion, and also why stars and galaxies recede away from each other. While much about the formation of the universe and its evolution has been theorized and plotted on the cosmic timeline, there are still enduring questions to be answered. With telescopes like Webb, we'll continue to hunt for the elusive dark matter, as well as look back into our universe to understand the evolution of stars and the formation of galaxies. Our quest also includes searching the cosmos in hopes of finding life forms to share our existence with. During the search, we've discovered exoplanets that orbit around a star outside of our solar system. Based on NASA's Kepler Space Telescope imagery, we can confidently assume that every star in the universe has at least one planet orbiting around it. In our galaxy of hundreds of billions of stars, it's believed that there are trillions of exoplanets. Yet we've only discovered around 3,900 of them. A little more than 4 light-years away, Proxima Centauri is the closest of these exoplanets, but scientists have their eyes on bigger things with the TRAPPIST-1 star system. This star system is home to 7 planets, all roughly the size of Earth, orbiting around a red dwarf around 40 light-years away. Our space telescopes, ground telescopes, and best scientists are working to try and understand whether any of these planets have the right ingredients for life to spring into existence. I made an entire video on what it would be like to live on one of these planets, the only one that scientists believe could possibly hold life. Whether we succeed in this mission is a story that will be written in the universe's future, one that will either propel us forward towards the understanding of the cosmos and our place in it, or will leave us pondering our lonely existence. Our universe is currently 93 billion light-years wide, filled with trillions of galaxies, and 1 septillion stars, that's 24 zeros, and it's still expanding through the vastness of space. Sometime in the distant future, it's estimated that our Milky Way will collide with the neighboring Andromeda galaxy. Because though the universe is expanding, galaxies are receding away from each other, and the proximity of the 2 galaxies will make the collision inevitable. Don't worry though, we'll be long gone before that happens. 100 billion years into the future, galaxies will disappear, and eventually, our universe will be populated by black holes ravenously eating away all that is in their way. As a new dark age sets upon our universe, astronomers believe that its fate is bound to end the same way that it began. With time, space will begin contracting again. The universe will shrink in size until one day, it devolves back into the singularity that started it all. A sort of big crunch reversal that'll bring things full circle and leave behind an emptiness aching to be filled. And then, Who knows? Bang. Today's video was sponsored by Brilliant, one of the best places online to learn anything and everything STEM related. To understand the history of our universe and our place in it, scientists for millennia have had to rely on physics and mathematics to help us figure out where we came from and where we're headed as a cosmos. Thanks to Brilliant, you no longer have to sit in a class for 4 years and pay hundreds of thousands of dollars just to learn these basic STEM principles. In preparation for this video, I took Brilliant's course on scientific thinking to help me understand the years of research that scientists have put into figuring out our universe and break those complex topics into this digestible video. If you're still watching, then you'll definitely agree that Brilliant helped me do a good job. There are currently thousands of lessons in Brilliant's catalog. With exclusive new content added every single month, there's just so much to learn on the platform. From anywhere in the world, you can learn more about STEM concepts and principles that will help you level up in every area of your life, from making better everyday decisions to understanding the history of the universe and our place in it. If you're interested in learning more, I highly recommend you check them out. It's free to start, but the first 200 people to visit brilliant.org/aperture will get 20% off a premium subscription, which unlocks every single course Brilliant has to offer. You'll not only be furthering yourself and your knowledge, but you'll be supporting Aperture at the same time.